Hello students, in our previous lecture we had finished one derivation of excess pressure. It was also called as Laplace law. Then we had derived an expression for height of a capillary rise or fall. Now it's time to solve numericals on those two formulas. Okay, first formula was Pi minus Po is equal to 2T divided by R. Correct? This was for liquid drop. And if it is soap bubble, then we will have to write 4T by R. First, I'll take the sum based on this formula. It is there in your textbook. It is a solved example number 2.6. I'm reading the question. What should be the diameter of a water drop? So we are supposed to find the diameter. Diameter is to be found out so that excess pressure is 80 Newton per meter square. Excess pressure value is given, that is Pi minus Po is given as 80 Newton per meter square. Okay, surface tension of water is given, which is capital T equal to 7.27 into 10 raised to minus 2 Newton per meter. So these all things are given. Okay, so let's use the formula. We know which formula we are going to use. It is a liquid drop, so this formula will be using Pi minus Po is equal to 2T upon R. Let's substitute the values. Solution. So here I will be writing 80 is equal to 2 into 7.27 into 10 raised to minus 2 divided by R. So therefore R can be written as 2 into 7.27 into 10 raised to minus 2 divided by 80. Got this? So when you solve this equation, you will get one answer. Okay? That answer will be definitely in meter because these all things are in meter. Okay? But we are supposed to find the diameter. So diameter is nothing but double of radius. So diameter will be written as 2 into R and 2 into this value you will substitute over here and you will get the final answer in meters. Understood? So this is how you are going to solve this sum. You can very well verify it from your textbook. Okay, let's move on to the next. Numerical, which is there from your unsolved exercise. Okay, which is there from your unsolved exercise and it is related to capillary rise. So what formula we had studied about capillary rise? It was H is equal to 2T cos theta upon R rho G. Correct? This formula we had studied. And the terms, you know, what are all these terms? So T is the surface tension, H is the rise in height or fall, R is the radius, rho is the density, G is the acceleration due to gravity. One more thing to be noticed over here, that if the angle of contact is acute, then we are going to use this formula. But in case of mercury, if the angle of contact is not going to be acute, it is going to be obtuse, then we will be using formula with some modification, which will be H is equal to 2T cos 180 minus theta upon R rho G. Okay, what is that modification? Cos 180 minus theta in case of mercury. Is it clear? I will take one sum related to acute angle. I will take one sum related to obtuse angle. First, let's go for acute angle. It is there in your unsolved exercise. Sum number is 18. Okay, I am reading the question. Calculate the rise of water inside a clean glass capillary tube. So, rise of water they have asked. So, I will write, we are supposed to find H over here. Capillary tube radius is 0.1 mm. So, R value is 0.1 mm. You will convert this into meter, which is 10 raised to minus 3, 0.1 into 10 raised to minus 3. It is immersed in water having surface tension 7 into 10 raised to minus 2. So, surface tension is 7 into 10 raised to minus 2 Newton per meter. No need to convert this, it is already in SI unit 7. Okay. Next, angle of contact is 0. So theta value is to be taken as 0 degree. Density of water, it is given 1000. Density is 1000. Okay. And value of G, which we know, it is 9.8. Clear? So we know the formula. Formula I will be writing. H is equal to 2t cos theta upon r rho g. Okay. So now you can observe in this formula we have the value of t, correct? It is given over here. We have the value of theta. It is given here. Cos 0 is 1. We are given the value of r, which you will convert it into meter and then substitute. This is 1000 and this is 9.8. So it is a very simple sum of only substitution, nothing else. So you can very well solve it at home and verify the answer from the textbook. Okay. Okay, let's move on to the next numerical. It is a solved example 2.7. Okay, I'm reading that sum from your textbook. A capillary tube of radius 5 into 10 raised to minus 4 meter. I've written it. Radius immersed in a beaker filled with mercury. This is a case of mercury. Okay, the mercury level inside the tube is found to be 8 into 10 raised to minus 3 meter below the level of reservoir. So mercury level is falling. So that is the height by which it is falling. So that is given 8 into 10 raised to minus 3. Surface tension is given 0.465. Okay. Density of mercury is given 13.6 into 10 raised to 3. G value we know 9.8. And they have asked to find the angle of contact. Okay. Here is the angle of contact. So just now I told you that for mercury, our formula will get modified and our formula will be H is equal to 2t cos 180 minus theta divided by r rho g. Correct or not? Now let's solve this sum. I'll be solving this sum till the end, till the last answer, because the calculation part is a bit difficult and you need my help for that. So I'll write the next step as 180 minus theta. This term is kept as it is. Rest all terms we will shift that side. So H R rho G divided by 2t. Let's substitute the values. H value 8 into 10 raised to minus 3. R value 5 into 10 raised to minus 4 into 13.6 into 10 raised to 3 into 9.8 divided by 2 into 0.465. Got this? Now, this term can get cancelled. Some terms you can directly multiply. 8 5s are 40. This also you can directly multiply. Okay. This also you can directly multiply. At some places, you might have to use log table so that you get a final answer of this whole term. Okay. So final answer I am going to write directly. This is your part to be done. Okay. My part is to explain how to take the angle of this, how to find out the angle. Okay, so when you solve this whole part, your last answer that will be coming is equal to 0.5732. I repeat, when you solve all this thing, your last answer will come as 0.5732. So on LHS, you have cos 180 minus theta. Okay. Now, our next step will be we will have to take cos inverse of this. So 180 minus theta is equal to cos inverse 5732. Okay. Now, you will require your log table. You will have to go into natural cosines. Okay. In natural cosine section, you will have to search this value in the table everywhere. Okay. So I'll just help you out with that. 5732 exact value you might not get, but definitely you will get 5736. Okay. It is there somewhere around 55 degree. 55 degree 0.5736. Okay, here in the column of 0 minutes. Okay, we are quite close to this. Now we want to get more closer to that 5736. We need 5732. So we will go to mean difference section. Okay, check mean difference section. In your natural cosines, over there, here it must be written subtract. Subtract must be written. Means whatever values you observe in mean difference, you are supposed to subtract it. Now, in mean differences, you can observe 1 minute, 2 minute, 3 minute, 4 minute, 5 minutes. 5 columns are there. Let me see 2 minutes. In 2 minutes section, come down. Against 55 degree, you will be observing a value called as 5, and here we have value as 3. Okay, so you have to subtract this. 5736 minus 5, you will get 5731, which is quite close to this. Did you understand? So we got a perfect value, quite matching with that. 5732 is not possible because we don't have 4 over here. So let's go to nearer one. Now, what is the angle in this case? You subtract this, but let me tell you, you add this. Okay? I repeat, you subtract these values, but these values are added. So your last answer is, this is your degree, 55 degree, and 0 plus 2 will give you 2 minutes. So 180 minus theta is equal to, the answer of this is equal to 55 degree 2 minutes. I hope it is clear. Now let me proceed. Let me proceed to the next part. Now our next step will be 180. This term will get subtracted. Minus 55 degree 2 minutes is equal to minus theta will go that side. So this will become plus theta. Now you are supposed to subtract this. Now for subtracting this also, we have to do some modification. 180 degree we will have to write as 179 degree and 60 minutes. Okay, 179 plus 60. Obviously, it is going to make 180 minus 55 2. This is how we are going to subtract. So 60 minus 2, I will be getting 58 minutes. 9 minus 5, 4, 2. And this will be equal to 1. So your last answer is 124 degree 58 minutes. Okay, this answer will match with your textbook. Now, many students must be thinking why this has been done. I'll give you a simple example. It is like our time clock. Okay, in case of time, if I ask you from 3 minutes, you are supposed to subtract 2 seconds. Okay, from 3 minutes, you are supposed to subtract 2 seconds. So what you will do? 3 minutes 0 0 minus 2 seconds. Correct or not? 3 minutes 0 second minus 2 seconds. So when you subtract this, if I am not wrong, 10 minus 2, you will get 8. Then this will become 9. You will get 9 over here. And this will become 2. You will get 2. So you will get answer as Am I correct or not? So you'll get answer as 2 minutes 98 seconds. But is 98 seconds possible after 2 minutes? No. Correct or not? So we got a wrong answer. Actual answer should be what? The actual answer should be 2 minutes 58 seconds. Correct or not? So what did we do wrong was we should not consider 0 over here. Instead, we should do something like this. We should have written 3 minutes as 2 minutes and 60 seconds. I hope you got this. Now I'll subtract 2 seconds. So 60 minus 2 seconds will give me 58 and this will give me 2. I hope you understood. We got the perfect answer. So in case of angles and in case of time, we are supposed to apply this method. Same method I have applied over here. Instead of writing 180, 00, I have written 179 plus 60. This is 180 only. And then we get a perfect answer. Okay, so this is how the sum is solved. Okay, students, let's move on to the next topic, which is fluids in motion. If you remember, I had taught you that we are going to study fluids in rest and fluids in motion. So this was part of fluids at rest, which we had already covered. And now we are moving for fluids in motion. So when we are studying properties of fluids in motion, that part, that branch of physics is what is called as hydrodynamics. So far we were in hydrostatics. Okay, so branch of physics which deals with study of properties of fluids in motion is called hydrodynamics. In this topic, first of all, let's get used to some common terms which we are going to use. Okay, so first one is steady flow. Steady flow, we say steady rate, go steadily. So I hope you can understand steady rate means constant speed, move by a fixed speed. So steady flow is also almost similar. If a liquid is flowing through a pipe, okay, and its velocity is constant, then it will be called as steady flow. So I have written it in short. You can very well observe it. Pressure or velocity of fluid is going to remain constant. It will not change. That is what is a steady flow. Second thing is flow line. Okay, I have drawn a diagram over here. This is a pipe. Inside this pipe, the flow of the liquid is shown. Okay, so if you consider one individual particle of that fluid, how it will flow. So we can easily show it like this by a line. This way it is flowing in one single direction. Correct? So that path of individual particle in a moving fluid is called as flow line. If you check this diagram, I must have shown flow lines equal to 6. 1, 2, 3, 4, 5, 6. I have shown 6 flow lines. Means 6 individual particles, how they are flowing in the pipe. That is what is your flow line. Next we have streamline. Okay. Streamline concept is quite easy. Just recollect the concept of electric lines of force. To an electric line of force, if we draw a tangent, okay, tangent is a line which just touches one point on a curve. If I draw a tangent to an electric line of force, what does the tangent show? That tangent helps us to know the direction of electric field at that point. Have you understood or not? So let me give you an example. If this is your electric line of force, like this, and I have drawn a tangent at this point, this way. Okay, so if you move in this direction, then that is the direction of electric field intensity at this point. Okay, if electric field was cut off at this point, then this is the direction of that electric field. Similarly, streamline also it gives the same idea. Tangent at any point gives direction of velocity of flow in a fluid. Right now, fluid is moving like this. But if I want to find at this point, where is the velocity pointing? Whether it is north direction, whether it is northeast direction, wherever it is. So what I'll do, I will just draw a tangent at that point, and that will give me the direction at that particular point. Maybe after some time it might change its direction. It might come bit downward, okay, because this pipe is not exactly straight, it is bended form, so flow will be get bent. So around this point, if I want to find the direction, I will again draw a tangent. Then again it will give me the direction of fluid at that point. So I hope you understood what is streamline. Okay. One thing I can tell you, flow line and streamline are almost similar in steady state. Steady flow, they are almost similar. If you draw the flow line or if you draw a streamline, it will coincide or it will remain parallel. Okay. Next, let's move on to flow tube. This is what is a flow tube. Let me tell you. The diagram that I have drawn is nothing but a flow tube. Flow lines surrounded by imaginary wall. As you can see, I have drawn 6 flow lines and I have covered it with a wall. That is what is a flow tube. Is it understood? So these are some basic terms of fluids in motion. I have written all these definitions in short. The actual definitions you can find it in your textbook and you can very well copy it and learn it. After this, we are going to move on to the next part, which is streamline flow and turbulent flow. If you remember the assumptions, we were considering streamline flow. Laminar flow also it is called. So now we are going to understand what is streamline laminar flow and what is turbulent flow. So let's move on to streamline and turbulent flow. Let's understand the difference between that. Okay, so I have very well shown it. Streamline flow is nothing but smooth flow, steady flow. Turbulent flow is irregular, unsteady flow. If I show you, if I tell you the examples, see, turbulent flow, flooded river, storm, you can understand. Turbulent, huge, like we cannot withstand such forces. Okay, river has flooded, full force is coming. Storm, we cannot stand midway of the storm. Hurricane, all such things are called as turbulent. Okay, they are not so smooth. Okay, they are with huge force, with huge velocity, and it may be result in some kind of circular motion. Correct or not? So that is an example of turbulent flow. Since the flow is steady, obviously velocity will remain constant. Since the flow is unsteady, velocity does not remain constant. Okay. In case of streamline flow, two streamlines means two flow lines will never intersect. They will go parallel. Okay, they will go parallel. Clear? Whereas here, since there is some rotational motion, one streamline is coming like this, another one is coming straight. So when one is coming straight, another one is coming rotational. So they will intersect. And this might result in eddies. Okay, some circular motion is formed. You must have seen huge waves. Okay, that is also coming in circular form. You must have seen circular storms, hurricanes. These all things are nothing but formation of eddies. Okay, simple example in streamline lakes, smooth water, whereas here there are lot many examples to understand. So this is how we complete the topic of streamline as well as turbulent.